Hello world, welcome back to my channel and to my second YouTube video. In the ever-going Leetcode grind as we all try to struggle to find a job, I worked on the valid parentheses problem today in Java. So I'll show you guys two ways to solve the problem, but let's walk through it first and pseudocode it out, and then I'll show you guys the switch statement method and then the hash map approach. So what is this problem? We're basically going to get a string called S, and when it's going to contain characters like smooth braces, curly braces, and square braces. And we just have to make sure that every smooth brace matches with every other smooth brace, and so on, right? And that there's no mismatching pairs. So what does that look like? This is a true example because this opening smooth brace has a closing smooth brace, and they're all both together. Same example here, right? Each type has mapped with its own type, so it lines up. This one is false because you can't have a opening smooth brace closed by a closing square brace. You can have nested braces, which is fine, right? But you can't have overlapping braces like this. Simple enough, right? So let's sort of dive into the algorithm. The core idea is that we need to go through the string and keep track of the ordering. And if you look at how this is done, it's actually a first in, first out ordering where we have to make sure that any character that comes in, it should be the first one to come out. So that way we can ensure that every type of brace matches up. And if they don't, then we know that we don't have a valid string. And the best way to do that in Java is actually using the stack data structure. So the idea is we would init a stack, right? And then for each character in the string, we would say if it's a opening brace, push it onto the stack. Then push it onto the stack. If it's a closing brace, then pop the stack and see if the matching opening brace is there. If not, then we have a bad string and return false, right? We do this for all the characters in the string, and if all of them are good, but we still have like a bunch of opening braces left over, then we know that if the stack is not empty, then it's a bad string. Otherwise, return true. So let's dive in and actually code this out. So we can initialize a stack using Java like this. Remember, we can't use char, but the actual character type because we are using this as a parameterized field. So we'll do that. We'll do a stack, new stack equals this. And then for each character in the string, we'll just do a simple for loop. Int I equals 0, while I is less than s dot length I plus plus. And this is the part where we can use the switch statement method I mentioned earlier. And after this, I'll show you guys how to do with hash maps as well. So let's get the current character just to make things easier to type later. We'll say that char current is equal to s dot char at I, right? And then we start our switch statement and we say for the current character, we say if it's an opening one, or and we add in all the types, right? We basically have to push it onto the stack. So we do stack dot push current, and then we break and we go on to the next thing in our for loop, right? And let's just move our pseudocode up here so we can just make sure we did that piece. So now let's add in the other case, right? If it's a closing brace, then we want to check is the stack empty because we don't want to have any null pointer exceptions when pulling values from the stack. and the stack that we pop, or the value that we get from the stack, if it is not empty, if it's not the corresponding opening brace, then we know that this is a bad string and we can return false. And we can rinse and repeat this logic for the other cases as well. Right? So we do that for the curly brace and for the square brace. Lastly, let's move our code up here as well so that way we don't forget about it and have it tracked just for neatness. We can do the final check, which is if we still have some opening braces left over, then we know that this is a bad string. So we can just return stack dot is empty, right? And that should work. So if you walk through the logic here, right, if we would add this to the stack, and then as soon as we go to this part of the string, we would pop the stack and see that, okay, these two align and they're good. And if we go to, let's say, the last scenario, right, we would add the first two characters to the stack, we would encounter this character, pop the stack and see a square brace, and we know that this is actually bad. And then we know that we can move on, right? So let's run this and see if Leetcode likes our solution. And it's clear that I messed up somewhere. So let's take a look and see it, because debugging is part of programming, right, guys? So clearly I messed up. And where could I have messed up for a simple case like this? I forgot to add break statements. Now we'd run it one more time. And it works. So we have a solution, and if you want to analyze the time complexity of this, it's actually O of n, because in the worst case scenario of us just getting all opening braces, the stack will get full and then we would loop through all the characters in the string at least once. Similarly, the space complexity is also O of n because, again, the stack is the main driver here. But you can tell, even just from me debugging this thing, there aren't issues in this approach. Like, if we had more character types, this would become really painful to manage. So I'm going to show you guys another method as well, which is a bit more scalable, but the logic is slightly more complicated. So let's go through that. The idea is very similar to what we had before, except that now we're going to use a hash map to actually keep track of the mapping and then rely on that hash map to know when we have the right matching pair. So we can initialize a map of characters, right? Hash map. And then we can just put in our mapping here. And the key is to make sure that you kind of put it in reverse order, where we say the closing brace matches the opening brace, right? So let's rinse and repeat this for the other types. We'll do closing, closing, opening, opening, right? And we're still gonna use our stack like last time to keep that first in, first out ordering. But this time, when we go through every character in the for loop, we're gonna do it a little differently, right? We can do a for each loop for every character in the string, because the string is nothing but an array of characters. If our map contains like this as a key, then we know that it's a closing character. I mean, if our map does not contain this as a key, then we know this is actually a opening brace, and we can push it onto our stack. Otherwise, we know that it is actually a closing brace, right? And then if that's true, then we can say if stack dot is not empty like last time, or map dot get c does not equal stack dot pop. Because remember, we're using the map to sort of know the ordering here, right? So we know that, okay, if we put in this closing brace, we should get this opening brace out, and then we can make sure that opening brace comes out of the stack, right? So we know if those don't line up, then we have a bad string, right? And then, like last time, we have to return a statement saying, is the stack actually empty or not? So we can just say return stack dot is empty, right? Just in case we have some extra opening braces. And you notice how this is a little bit simpler and easy to extend. We can just add more characters here, right? And the key here is just, of course, that we are assuming that, if a character doesn't match our keys in our map, then it's a opening brace, and that every opening brace has a matching value in our map, so that when we do the pop, it should align. So let's run it and see if we got it right. And that also works. So if you want to analyze the time and space complexity of this one, it's actually the same as the solution before, because the map itself is constant, so it's actually O of 1. It's a stack itself, which we have to go through the string. So we go through all characters in the string at least once, so it's O of n. And the stack itself could be entirely consisting of like opening characters. So again, the space is also technically O of n. With that said, that's pretty much the solution to the valid parentheses problem. I hope you guys like something. Please comment if you have any questions, and like and subscribe if you enjoyed this kind of content. Good luck out there, and I hope you all do well in your interviews.